So the reason we've been doing simplifying rational equations and working with adding and subtracting expressions is to finally get to solving rational equations. So we are going to be looking at two different types of rational equations. We're going to be looking at proportions, which you have seen before, and then we will also be looking at our standard simple rational equations, which we will get to in part 2. So the goal of all this is to be able to solve rational equations and be able to check to see if those solutions are extraneous or not. So we're looking to solve and check for extraneous solutions, and this is a standard proportion. So you saw this in Algebra 1, you saw this in geometry, solving by cross multiplying. But why are we solving by cross multiplying? Because what's really going on here is we want to get common denominators. And in order to get common denominators, you have to multiply by the opposite. So let's just look at one going through with solving it by getting common denominators, and you'll see it's the same thing as cross multiplying. So right now I have x and 16. So I want it to be 16x. Because I can't make x into 16 or 16 into x, I just want to combine them together. So that would mean I would multiply this by 16 and this by 16, and then I would have to multiply this by x and this by x. So what you can see is happening is I cross multiplied essentially 16 times 5 and 10 times x. That's what I did here. So if I do 16 times 5, I get 80 over 16x, and that's going to be equal to 10x over 16x. And when we're solving a rational, the denominator, once it's the same, we can just solve for the numerator. So we essentially solve the numerator. 80 equals 10x. We do the inverse operation. 10 is being multiplied by x, so the opposite would be to divide, leaving us with x is equal to 8. So this would be our answer as long as it's not extraneous. So to check to see if something's extraneous, well, look at the denominator, and remember we said what makes the denominator not work? Well, when it's 0, because that gives us an undefined answer in our denominator. So obviously we have a whole number in the denominator. That doesn't do anything against us. It just is that number, which is fine because it's not 0. And if we have x, we know that x cannot be 0. So as long as x is not 0, then we're good. It's not an extraneous solution. So as long as it's not one of the domain restrictions, it is in fact an actual solution. And you can see that when you plug in x equals 8, it doesn't give you 0 in the denominator, so it works. So 8 is our solution. So we kind of went through and saw, well, why does cross multiplication work? So now, moving forward, if you have a fraction equal to a fraction like this, you can just go ahead and do cross multiplication. So example number 2, we want to solve and check for extraneous solutions. So the first thing that we can do here is we can see, well, what is our domain restriction? What can x not be at the end? And then we know what we have for possible extraneous solutions. So here we know that our domain is x cannot be 2, because 2 minus 2 is 0, and x cannot be negative 2, because negative 2 plus 2 is 0. So this is our domain restriction. So if we get x equals 2 or x equals negative 2, it's an extraneous solution. So you could always start with that, or you could go back and do it at the end. From here, essentially we have to multiply the first equation, or the first rational fraction by x plus 2, and the second one by x minus 1, or x minus 2. So when we do that, the denominators become the same, and we just solve the numerators anyways, so we can cross multiply. So we have 5 times x plus 2, and that's going to be equal to 1 times x minus 2. So when I go ahead and distribute, I get 5x plus 10 equals 1x minus 2. So from here, it's very basic solving. Hopefully we can do from Algebra 1 and lots of things we've already done this year. We need to get all of our x terms combined together. So to do that, I'm going to subtract x. And that's going to give me 5x, undo that. That's going to give me 4x, because 5 minus 1 is 4, plus 10 equals negative 2. But then I need to get the numbers on the other side, so I'm going to subtract 10. And then that's going to leave me with 4x equals negative 12, and then finish by dividing by 4. So I get my solution is x equals negative 3. Since that is not one of my domain restrictions, it is my solution, because it's not going to make the denominator 0, and it's going to make my two rational equations equal to each other. And I can always go back and plug negative 3 in to make sure that it does in fact work. I will do it this time to go ahead and check, but because I know it's not a domain restriction, I know it's not extraneous, but I can always check just to make sure it is in fact the correct answer. So I had a 5 over negative 3 minus 2 is equal to 1 over negative 3 plus 2. So that's going to give us 5 over negative 5 equals 1 over negative 1. So negative 1 equals negative 1. It works. For our third example, we want to solve and check for extraneous solutions in this rational equation. And if we look at this and we look at our domain, our domain can be every number except x cannot make the denominator 0. So what's going to make the denominator 0? Well, if I look at the left fraction, 1, because it's the opposite. So 1 minus 1 is 0. And the second one is also 1 minus 1. So that is my only domain restriction, is x cannot be 1. So you may notice here, my denominator is already the same. It's x minus 1 and x minus 1. So if your denominator is the same, you don't have to multiply by anything. It's just solve the numerator. So we can get rid of our denominator and just solve our numerator. Well, our numerator is x equals 4. So that is our answer because it's not one of our domain restrictions. Now, you could go through and cross multiply if you don't recognize that right away, and you would get x times x minus 1 equals 4 times x minus 1. And you would get x squared minus x equals 4x minus 4. And once we have an x squared, just like we did with radicals, we have to get everything to the same side, set it equal to 0 so that we can factor. And to do that, I would have to subtract 4x, and that can go with the x term. And that's going to give me x squared minus 5x equals negative 4. Well, then we can add over 4 and get x squared minus 5x plus 4 equals 0. Well, then we have to factor. And when we factor, we get x minus 4, x minus 1. So what are our solutions? Well, 4 and 1. So we have to check for extraneous solutions. How do we check for extraneous solutions? We look at our domain restriction. X cannot be 1. So that means X cannot be 1. That would be an extraneous solution, and 4 would be our only solution, which was the same as when I just set the numerators equal to each other. So if you can recognize that the denominators are already the same, just solve the top, that works. Or cross multiply and you end up with the same answer, just a little bit more work. We have 2 more examples left. I'd like you to try this one on your own. So example 4, solve and check for extraneous solutions. So find your domain restriction and then go through and solve by cross multiplying to figure out what X is. Make sure to check to see if it's extraneous or not. Remember, if something's extraneous and you only have one solution, it's no solution. So go ahead and pause the video, try this one, and then hit play to check your answer. All right, so hopefully you got 3 and -1, and they both are solutions because our domain restriction is X can't be 2. Well, 3 and -1 aren't 2, so they both work. And if you plug them back in, you should see 3 over 3 is 1. 1 equals 1 over 3 minus 2, which is 1 over 1. So 1 equals 1. That works. Plug in -1, -1/3 equals 1 over -1 minus 2, which is -1/3. So they both work when you plug them in. So you cross multiply, you distribute, you have to get everything to the side with x squared to factor. From the factors, find your solutions, and always just verify that they're not extraneous solutions. They don't make the denominator 0. So they're not one of your domain restrictions. And our last example, looking at a little SAT practice here while solving rationals. So it says, given this equation here, what are all values of x that satisfy the equation above? And you got some answer choices. Well, let's just solve first and then go back and check those answers and see which one works. Now, if this was the SAT, you could always plug them in and see which one is the correct solution. If you get stuck, just plug in -3. Does it work? Plug in 0. Does it work? But let's go through and actually use our technique to solve and then choose the correct answer. All right, so we have x squared minus 1 over x minus 1 equals -2. Well, if we have a whole number can be written as a fraction. It's just over 1. -2 over 1. When you divide, you get -2. Now it's just written as a fraction. So from here, I have a fraction equal to a fraction. I have a proportion. I can solve by cross multiplying. So when I do that, I get 1 times x squared minus 1, which is just x squared minus 1. And then -2 times x minus 1. All right, so let's distribute. When we do that, we get -2x plus 2. Well, we have an x squared, so we need to make sure to get everything to one side, the side with x squared, so that it stays positive. So to do that, I'm going to add over 2x. That's going to be by itself because it doesn't have a like term. And I'm going to subtract 2, and that's going to go with the -1. So that gives me x squared plus 2x minus 3, because these two combined together, -1 and -2, equals 0. Well, now I can factor. And when I factor, I get x plus 3, x minus 1, because 3 times -1 is -3, and 3 minus 1 is 2. So what are our solutions? Well, x equals -3, and x equals +1. However, got to check for extraneous solutions when we're solving rationals or radicals. I forgot to do the domain restriction to start on this one, but you can always do it at the end. So my domain restriction would be what's going to make my denominator 0 or undefined, and that would be 1. If it's just a whole number, that's not going to make any difference in a domain restriction because it's just a whole number. So this is what my x value cannot be. So this one is an extraneous solution. It's going to make the denominator 0. So my answer is x equals -3. And when I plug that in, I should see that it works. So that gives me the answer of A, -3. Because D isn't right, C isn't right, that was our extraneous solution, and B doesn't work either. So that is solving rational equations if we have a proportion. So this concludes part 1. So you can complete part 1 on your 5.5 worksheet.